Hello everyone. In this video we are going to study about the various confirmatory tests used for the presence and confirmation of nitrogen in our organic compound. So one of the oldest methods for confirming nitrogen was called soda lime test. In this particular test, what we do is we simply take a pinch of our organic compound and heat it strongly in the presence of soda lime, which is nothing but NaOH plus CaO. Now what happens is that when we do this particular reaction, evolution of ammonia gas takes place. Now this particular evolution of pungent ammonia gas confirms the presence of nitrogen. Let's take an example here. Here we have CH3CONH2, which is acetamide. We know that CONH2 is nothing but amide functional group. So when this particular amide is heated in the presence of soda lime, what we get is ammonia gas along with the sodium acetate formed here. So you can see that this particular pungent ammonia gas confirms the presence of nitrogen. A very important limitation of this particular test is that if nitrogen is present in the form of nitro group or azo group, then this particular test fails because ammonia gas is not evolved under the above given conditions. Let us now look at the most commonly used confirmatory test for nitrogen, which is the Lassigne's test. So in the Lassigne's test, obviously the first step is nothing but preparation of Lassigne's extract. That would be a first step. And you need to note that the Lassigne's extract needs to be alkaline in nature, so we add a few drops of sodium hydroxide or NaOH. In the second step, the sodium fusion extract is boiled with iron sulfate or FeSO4. In the third step, what we do is simply add 2 to 3 drops of FeCl3 solution followed by acidifying the reaction mixture with concentrated HCl. Confirmation of nitrogen is done with the formation of a Prussian blue colored complex that is formed. Let us now look at what are the reactions involved in this particular test. So you can see that the first step is nothing but preparation of sodium fusion extract. So we know that if we have nitrogen in our organic compound, then nitrogen combines with sodium giving us NaCN. The next step what we are doing is we are heating the sodium fusion extract with iron sulfate. So we know that our alkaline sodium fusion extract is alkaline in nature. So FeSO4 reacts with sodium hydroxide giving FeOH twice complex along with sodium sulfate. So what happens is that this particular complex is nothing but green in color. Now this complex, that is ferrous hydroxide, reacts with 6 moles of NaCN giving us finally sodium ferrocyanide, which is Na4FeCN6. We remember that in the third step what we are doing is we are adding FeCl3 solution. So here we add FeCl3 solution to sodium ferrocyanide to give us a final complex, which is ferric hexacyanoferrate, also called ferric ferrocyanide. So this particular complex is what that gives us Prussian blue color and hence confirms the presence of nitrogen in our organic compound. Please note that these are very important reactions and are very important also in terms of your competitive examination point of view. So please also make sure that you also remember the mole ratio of the various reagents used here. Another important thing to remember is that we are adding concentrated HCl in our last step. What is the significance of this particular reagent? What happens is that we know that in the second step we got FeOH twice ferrous hydroxide, which is green in color. So in order for this particular ferrous hydroxide to not interfere with our final complex, which is Prussian blue, what we do is we add consonant HCl, which converts this particular hydroxide to insoluble FeCl2 here. Now you can see that what happens if we have both nitrogen and sulfur present in our organic compound. In that case, thiocyanate or SCN minus ion is formed, or sodium thiocyanate is formed instead of sodium cyanide. That is because no free CN minus is present in a sodium fusion extract as they combine with sulfur giving us NaSCN instead of NaCN. So consequently in the final step when we are adding FeCl3 solution, what we get is a red color, that is a blood red colored complex corresponding to FeSCN2 plus complex instead of the Prussian blue colored complex that we had seen in the previous case. So this is essentially what happens if you have both nitrogen and sulfur. Note that we get blood red colored complex and not Prussian blue colored complex. In case we are preparing a sodium fusion extract with excess of sodium, in that case the sodium thiocyanate NaSCN formed with reacts with sodium, excess sodium, to give us NaCN and Na2S, that is we get sodium cyanide as well as sodium sulfide in this particular reaction. So now we can individually carry out the confirmatory test for both nitrogen and sulfur in these cases, as NaCN will not interfere with the detection and confirmation of either of these two elements. I hope you are very clear in case what happens when you have nitrogen and sulfur present. Also, what are the various steps involved in the Lassigne's test as a confirmatory test for nitrogen. Thank you.